All right, here we go with a review on variables. Why in the world did we stick the alphabet in math? I've often heard people say this, hey, I was good at math before they decided to mix the alphabet in it. Good heavens, what are we doing with numbers? Well, let's look at an example as to why we started putting the alphabet in math and what happened and where it came from. So here's a scenario. Suppose we have 6 kids. They're going to a little hamburger place to buy hamburgers. And we're going to look at how much it costs them. So they have 6 kids. Each one costs $1. You're like, wait a second, I know how to figure out what the total cost is. You've got 6 kids, $1 apiece, 1 plus 1 plus 1 plus 1 plus 1. That's 6 times 1 equals 6. $6 total cost. What if the price changes to $2? We now have a completely different problem. 6 kids now go to the hamburger place and it's $2 a piece. Well, I know how to find out the total cost. You got 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. That's 6 times 2. That's going to be $12 is now the total cost. What if it bumps up to $3? Well, we know how to do that one, but that's a completely different arithmetic problem. You have 6 times 3 now. That's a totally different problem. You now have $18. What if it went to $2.30 each hamburger? So then, now you got 230 plus 230 plus 230 plus 230. You can only do this so many times before you realize, oh my goodness, we're doing the same thing. Now, when you think about the same thing, that means you're not doing the same problem. These are all very different arithmetic problems, but they all follow the same pattern. And so you write down what that pattern is. And you say, well, I take whatever the price is and I times it by 6. That's my pattern. So I'm going to take 6 times whatever the price of the hamburger is. And that's going to equal my total. You're like, really? That will always happen? What if the price were, I don't know, $7? Would it still work? Well, yeah, we're doing the same thing. And you'd put $7 right in here into this pattern, and it would be able to produce what your total cost is. And this simple little example here shows you what humans have done. They were doing problems and solving problems over and over until they were able to group them into one set of problems that all followed the same pattern. And so they would write it down. They would write down the pattern right down here. And this pattern of solving a problem, that is actually where a formula comes from. That's what a formula is it is a pattern for how to solve a problem. And instead of writing price out and total out, they just picked the first letter or a letter of the alphabet to represent those possible changing numbers. So here they would write 6 times the price equals the total. So whenever you're given a formula, somebody has to tell you what the P stands for, what the T stands for. Otherwise, it doesn't make much sense. So this is why the alphabet came into math, because this guy is no longer constant. See, he can change all over the place. He can be this guy or that guy or that guy. He could be any number in this pattern, and that he varies. That's why they call him a variable. He's a number, but we just don't know what he is yet. And so that guy changes as well. You see, he's changing like crazy. So it's a variable instead of something that is always constant. That's where the alphabet came from the human ability to generalize all of these arithmetic operations into a pattern and see it on more abstract level. And so we represent that with a letter. Now, we're going to leave that for a bit and talk about what happens because we now have letters. You'll notice here that we have a kind of a big concern with this guy. He could be an X now. If we allow the alphabet in math, look at that. Somebody decided to mix the alphabet in math. That means the X could be an X. It could be a number that we just don't know. It could be a variable. So instead of this one, when you start getting into algebra and pre-algebra and using variables, we no longer use that for times. We do other things. And so what used to be an X for times, we've picked another symbol, a dot, or you can write things that are next to each other. And all of these symbolize multiplication. So, for example, here you could write 6 times 8 would give you 48, or 6.8 would give you 48, or 6 right next to the 8. Oh, well, that doesn't make any sense. That looks like 68. Ah, if we separate them like this, then the 6 and the 8 are separate numbers. Oh, you could write it like that too. Or you could write it separating them both out into their own things. When you see the parentheses just group it, but it is the next two that causes it to work. So if we look over here at some of these things, 6 times 3 could be written 6.3 or 6.3 like that. Or you could put parentheses around just as long as it's separated and you don't see a 63 here. So when you start using variables, instead of 6xp, once you get to algebra, you just don't use this column anymore. So I could write 6.p or just 6p. Notice when I've got a variable, there's no discrepancy there. There's no ambiguity. It's not 60p, it's 6 times whatever the price is, which kind of makes sense. You got 6 prices, or 6 sevens, or 6 threes, or 6 twos, or whatever goes in for p. So 7 times m, well, you just write it as 7m. So this is how multiplication happens. So when you have something like 2 times 3 times 6, you just go 2 times 3 is 6, times 6 is 36. So you use that. Or if you have 2 parentheses, 5 plus 8, this is now 2 times 13, which is 26. Good, that introduces variables for you.